Alright guys, today we are going to be focusing on solving quadratic equations, but before we do that, what I'd like to do is check over your homework answers. So go ahead and take that out right now. You can pause this video to give students time to take out their homework answers. Alright, now that you have your homework out from last night, I'd like to take a look at your graph. So looking at this graph, here we have y equals x minus 2 squared plus 4. Your vertex will be at 2, 4. Remember, opposite the sign in the parentheses, and keep the sign outside the parentheses, and then we get our table from here, plot the points. Domain is all real numbers. Range, when we look at this, the lowest value occurs at the vertex, where y is 4, and then it will be anything above that, so it's y is greater than or equal to 4. If you had anything incorrect about this graph, go ahead and make your changes now. The next one, notice here the vertex would be negative 4, positive 7, because it's opposite the sign in the parentheses. Excuse me, we have negative 4, 7 in the middle. We get the rest of our table here, and we get our parabola that looks like this. It is opening down because of the negative out front. And then it will be a vertical stretch because of that 2. That's narrower than the parent function, y equals x squared. Our domain is all real numbers again, and our range, because the highest value is 7, and it's anything below 7, would be y is less than or equal to 7. And then finally, for our last graph, we have our vertex is 0, negative 7. We're not subtracting anything from x before it's being squared. And k is negative 7, so there's our vertex. We make our table either side of the vertex, and we get this parabola opening up because a is positive. Our domain is all real numbers, and our range, if we look at this, our lowest value is negative 7. It's anything above negative 7, so y is greater than or equal to negative 7. Again, make any changes you need to make on your graphs because they're going to be important for our notes for today. What I'd like you guys to do right now is take out a sheet of lined paper. We're going to take our notes and our warm-up on a lined sheet of paper today. Don't put your homework away because we're going to come back to this before the end of class. So taking out a sheet of lined paper, please title your notes 7A5 notes. The title of today's notes is Solving Quadratic Equations. Solving quadratic equations. We have been graphing quadratic functions. Today we're solving quadratic equations. So let's pick apart this title real quick. When you solve something, we have to think through, well, what would our final answer look like? Anytime we were solving equations, our answer looked like x equals something or y equals or something like that. So our answers today are going to be a variable equals something. Now quadratic. Quadratic is the family that we're studying now. Think through in our heads. What does it mean to be quadratic? Well, every graph that we've been, or every equation we've been graphing has had an x squared in it. So today, every equation we see is going to have an x squared somewhere in it. And then finally, equations. Equations we know are mathematical sentences that have equal signs. So everything today you are going to see has an equal sign, and we're going to have to solve. In your textbook, this is going to be section 10.4. So if you would like to look in your textbook, you can look in section 10.4. We're going to solve quadratic equations today by a certain method, and the method we're going to use is solve by taking the square root, and we'll get to that in a little bit. So your warm-up, the directions are going to be solve. Remember, when we solve, our final answer should look like x equals, y equals, whatever variable you're solving for equals. For A, we have x squared is equal to 121. For B, x squared is equal to the square root of 50. And C, sorry, not square root of 50, just 50. Let me get my white out. I apologize, guys. X squared equals 50, not square root of 50. There you go. So x squared equals 50. And then finally, x squared equals negative 81. So you can pause this video right now, and while the video is paused, go ahead and try and solve these equations. Remember, you're trying to figure out what could x equal so that when I square it, I get 121. What could x equal so that when I square it, I get 50? And same thing here. Go ahead and pause the video and solve these three problems. All right, now that you've tried these on your own, I want to talk through what do we get for x? Well, when I'm looking at this, I'm thinking I got to square a number and get 121. Well, there's actually two possibilities. If 11 squared is equal to 121, but there's another number that if I multiply it by itself, I get 121. And that number is a negative 11. Negative 11 squared is just negative 11 times negative 11, which is positive 121. So for our answer here, we get two answers. We get x equals 11 and x equals negative 11. And there's actually a shorter way to write this. You're going to start seeing x equals plus or minus 11. So here's one way to write your answer, and here is another way. This is called plus or minus. And you're going to be seeing a lot of that now. It's essentially saying you got really two situations. You got either positive 11 or negative 11, but it's a shorter way to write this. Now, some of you may look at this and you know what times itself is 121, but some of you may be thinking, I have no idea what squared is 121. And there's something we can do on our calculators in order to figure this out. So what I'd like you guys to do right now is get your calculators out. And on your calculators, I want to show you how you can use your calculator to do an operation that will solve for x. Now you guys have, when we solve equations before, we've been doing inverse operations. The operation that's happening at x right now is a squaring. To undo squaring, or the inverse of squaring something, is square rooting. So I'm going to go to my calculator, and if you look at this, you see that blue square root here? Right by the x squared. If I press second and then that, I can put 121, and it'll give me 11. It always gives you the positive root, so just be aware that even though you take the square root and you get 11, there's really two possibilities. All right, so let's make a little note under here. I could take the square root of both sides, and I can come down here. Square root of x squared is x. Square root of 121 would be 11, but we know it's really two possibilities. So let's make a little note here. Squaring and square rooting are inverses. They undo each other. They are inverses of each other. So when you take a look at x squared equals 50, I'm trying to think, what number squared equals 50? Well, if I think about this, I know that 7 squared is 49. So I got to be bigger than 7. So 8 squared is 64. Well, 50 is between these two, which means x has to be between 7 and 8. And it's going to be closer to 7 because 49 is pretty close to 50. But I want to try and figure out, well, what exactly is this? So we can figure out the approximate answer by using our calculator. If we square root both sides, we get x. I'm going to look here. If I take the square root of 50, I end up getting a decimal. Now we see it's between 7 and 8, but definitely closer to 7. 7.071, etc. So I'm going to use a little squiggly lines. These mean approximately. This is not exactly equal to this. This is approximately 7.07. We'll round to the nearest hundredth. Okay? But realize that 7.07 squared will give me 50. So will negative 7.07. So you have two possibilities here. This is plus or minus 7.07. That's the faster way to write it. And you got that right there. Now, this is an approximate answer. So go ahead and write next to this, approximate. That is not the exact answer. Approximate because we had to round that decimal. If you want the exact answer, we got to do what we did yesterday. So I'm going to put a little squiggly line here. Now we're going to focus on the exact answer. If we have x squared equals 50, we take the square root of both sides. We will get x is equal to the positive and negative root of 50. Yesterday we talked about how to simplify this. In order to simplify this, I'm going to do this to the side here. Well, I guess we'll do it right below. I have square root of 50. I know that 50, there's a lot of things that multiply to be 50. In my head, I think 5 times 10. Now I'm thinking, well, what multiplies to be 5? Well, 5 times 1, 5 is a prime number, so I'm going to circle that guy. Now 10 is not a prime number. I know that 5 times 2 is 10. 5 is a prime number, 2 is a prime number. Go ahead and pause this video so that you can finish simplifying this radical on your own. All right, now that you've done it, let's check our answers together. We have this is equal to the square root 5 times 5 times 2. Well, I'm going to group these. That's 5 squared. Square root of 5 squared times 2. I can break this apart to the square root of 5 squared times the square root of 2. I know that the square root of 5 squared is 5. Square root of 2, I can't simplify that, so that's just 5 times the square root of 2. So jumping down here, my final answer, if I want the exact answer, is x is equal to plus or minus 5 times the square root of 2. And that will be my final answer. Here is your exact answer, here's your approximate answer. I can show you on the calculator, they are the exact same thing. 5 times the square root of 2, if I press enter, I get the exact same thing here. This one is in simplified radical form. Here's your decimal approximation. So notice both of these, they both have 2 solutions. Let's go up here. X squared equals negative 81. I'm trying to think to myself, well, what squared will give me negative 81? Well, I know 9 times 9 is 81. So if I do 9 squared, that's 9 times 9, that equals 81. Well, I want negative 81, so let's try negative 9. Negative 9 squared is negative 9 times negative 9. That's positive 81 again. Now some of you might say, well, I got negative 81 when I put in my calculator. If you do negative 9 squared in your calculator and you press enter, you are going to get negative 81. The reason why, though, is you're not squaring the negative. You're only squaring the 9 and then you're making it negative. So to really do negative 9 times itself, or negative 9 squared, we have to have the parentheses. So don't forget that. So there's nothing that when you multiply by itself will give you a negative number. Positive times a positive is positive. Negative times a negative is also positive. So here, there is no real solution. Now in the past when we had no solution, we just wrote no solution. I'm telling you it's no real solution because there is a solution to this. It's just not real. Now you may ask me, well, what's the difference between what number would not be real? All numbers are real. There are actually imaginary numbers. So if I take the square root, in your calculator, if you try and take the square root of negative 81, it'll say error, non-real answer, because the answer is not real. But we are going to do what the imaginary solution is. You will not learn this until Algebra 2, but I'm going to show you right now in case you're interested. If I take the square root of negative 81, I'm going to break that apart into the square root of negative 1 times the square root of 81. Now, square root of negative 1, there is an imaginary number that represents that. That imaginary number is I. We represent square root of negative 1 with I. So it's going to be I times square root of 81 is 9. So if you want to write the imaginary solution, you would say x is equal to plus or minus 9i. That is your Algebra 2 answer. You won't have to be worried about that. Algebra 1, I'm just concerned that you can say no real solution. So if you have something squared equals a negative number, you get no real solution. And that real is important because there is a solution. In fact, there are 2 imaginary solutions. So you have no real solutions, but you have 2 imaginary solutions. All right, so we solve quadratic equations. We're going to get to a little more complex quadratic equations now. So go ahead and take back your homework that you guys had here. And we're going to solve the equations just like we did with absolute value, both graphically and algebraically. So when you look at this, we have our graph, and we want to know what is x when y is 8. So if we look at our graph, when y is 8, that's here, we have 2 parts. Or you can look here and here. When y is 8, x will have to be 0 or 4. So x is either 0 or 4 when y is 8. Let me show you how we get this algebraically. So scooching over here. We substitute 8 into the equation. So we will have 8 is equal to x minus 2 squared plus 4. Solving this equation, we're still going to do similar operations to what we've done in the past. You keep doing inverse operations until you solve for x. Okay, when we do this though, just like with absolute value, we want to isolate what is being squared. So when I look at this, I'm asking myself, well, what's being squared in this equation? Well, x minus 2 is being squared. So I'm going to block this in. Just like I did with absolute value, you want to isolate the absolute value first. Well, in order to do that, I'm asking myself, what can I do to both sides in order to start getting x minus 2 by itself? Well, the first thing I'm going to do is subtract 4 from both sides. When I do that, that adds to be 0, and I'm left with 4 is equal to x minus 2 squared. So now I'm thinking to myself, I still want to get that x by itself. I've isolated what's being squared, so now I have to undo the squaring. So, how do I undo squaring? Well, we talked about it before. The inverse of squaring something is square rooting it. Square rooting it. So, when I take the square root of both sides, or I'm thinking what's squared is 4, I'm just left with x minus 2. And we don't really need the parentheses anymore. So I started the parentheses, but once you undo the squaring, you don't really need it. Let's just white that out. We don't need that. Okay? And the square root of 4 is 2. But we've got to think about this. We know that something squared that equals 4, well, 2 squared is 4, but there's another number that when you square it, you get 4. And that is negative 2. So this is where we're going to write plus or minus 2. So let's just make a little note, a little rule of thumb. Whenever you take the square root of both sides, include a plus or minus right away. So as we took the square root of both sides, do plus or minus 2. Well, now this is going to look very similar to our absolute value equations. So x minus 2 is either equal to 2 or x minus 2 equals negative 2. So here I'm breaking into two equations. X minus 2 is equal to 2 or x minus 2 equals negative 2. And this is how we'll get our two solutions over here, like we saw on the graph. Add 2, I get x is equal to 4. Add 2, I get x is equal to 0. So we have two solutions, and we just got those solutions by doing inverse operations. Next problem, we're looking at this. We're trying to figure out what is x when f of x equals negative 11, or what is the input when the output is negative 11. Well, negative 11 is way down here, okay? Or if we look in our table, it's going to be somewhere up here, somewhere down here. I don't have that in my table yet, but we could get that. So there is a solution. This goes on forever. So even though my graph doesn't show it, this really goes on forever, and we're going to get two solutions again. Now, I just can't see it in the graph, and I don't have it in my table, so let's do this algebraically and see if what we get looks like it would be about in those two locations. So looking over here, we substitute f of x with negative 11. Negative 11 is equal to negative 2 times the parentheses x plus 4 squared plus 7. Again, we're going to solve this doing inverse operations. We want to isolate what's being squared. So we're going to isolate that guy, meaning we got to get rid of that 7 and rid of that negative 2. Go ahead and try this on your own, and let's see how you guys do. So pause the video, try this on your own. All right, now that you guys have tried this on your own, let's talk through this together. We want to isolate what's being squared. So first step would be to subtract 7 from both sides. Remember, we do the inverse order of operations. So this is multiplication, this is addition. So to solve, we subtract 7 from both sides. That adds to be 0. And on the left-hand side, we have negative 18 is equal to negative 2 times x plus 4 squared. Now, some people like to try and distribute this. We said we couldn't do this with absolute value. When these were absolute value bars, you couldn't distribute the number because absolute value are not like parentheses. But now we have parentheses again. So some of us might think, well, why can't I distribute that? Distributive property only works when you don't have something squared. So I'm going to make a little note over here. Distributive property says A times B plus C is equal to AB plus AC. Notice there's nothing being squared up there. That is your distributive property. But when I have something squared, I can't distribute. So make a note, cannot distribute if squaring the parentheses. Okay, so we can't distribute. So we got to get rid of this -2 in another way. In order to do that, we know that that's multiplication. The inverse of multiplying is dividing. I divide both sides by -2. Those divide to be 1, so I'm left with positive 9 is equal to x plus 4 quantity squared. Now I've isolated what's being squared. It's all by itself, and I still have to continue to do inverse operations in order to solve. So I take the square root of both sides. I have x plus 4 on the right-hand side, and on the left-hand side, I know the square root of 9 is 3, but I'm not just going to write 3, because I know that not only 3 squared is 9, but -3 squared is 9. So we have plus or minus 3, which means we really have two equations we need to solve. We need to figure out, well, what would x be if x plus 4 is 3? And what would x be if x plus 4 is -3? So if I subtract 4 from both sides, I get x is equal to -1. And subtract 4, x is equal to -7. Well, let's look and see if this makes sense. Going back to our graph, does this look like this could be -1, -11? Yeah, it does. What about this side? -7, -11. Yeah, that looks like that could be right. And if we go back to our table, if you use your graphing calculator to go in your table, or if we just substitute -7 into the equation, or -1 into the equation, you'll see that you do get -11 here. Now, some of you guys may have already had that in your table, but if you didn't, you can include that now. So again, a situation where we have two solutions, because this horizontal line is intersecting this quadratic equation, or this parabola, in two places. All right, and then moving down here, we have another problem. We want to find, well, what is x when y is 9? So if we go to the graph, we go to where y is 9. We have two possibilities. Now, I can't really see where they intersect, so let's go to the table. Well, y is 9. Well, y is 9 somewhere between here, and somewhere between here and here. So we're actually going to have a solution this time that's between -3 and -2, and between 2 and 3. So let's see what that looks like, or what happens algebraically when we solve a problem like that. So scooching over here to the right, ignore this line here. I don't know why that's there. It just happened when I was copying. Substitute in 9 for y. We get 9 equals 2x squared minus 7. On your own right now, go ahead and try and solve this quadratic equation using inverse operations. Pause the video and try this on your own. All right, now that you have tried it on your own, let's take a look. We want to isolate what's being squared. The only thing that is being squared is the x. There's no parentheses, so the only thing being squared is the x. So I just have to isolate what's being squared. So I add 7 to both sides. I get that 16 is equal to 2x squared. I still have not isolated what's being squared yet. I need to divide by 2, because if that's 2 there, we're multiplying. The inverse is division. So I get 8 is equal to x squared. So now we're thinking, well, what squared is 8? Well, no integer squared will give me 8, because I know that 2 squared is 4, 3 squared is 9, so it's some number between 2 and 3, or between -2 and -3. So we'll do our inverse operation, square root, square root. Well, the square root of x squared is just x, no big deal. Over here, we have plus or minus the square root of 8. Now, if you use your calculator, I punch out in my calculator, I get x is approximately plus or minus 2.82. This is your approximate answer. On your homework, I don't want approximate answers. I want the exact answer. So over to the side here, we need to simplify square root of 8. Pause the video right now and try and simplify this on your own. Now that you've tried simplifying it on your own, let's break this apart. We know that 8, well, 4 times 2 is 8. 4 can be broken apart to 2 times 2. Well, 2 is a prime number, so I'll circle it. 2 here is also a prime number and a prime number. So this is really the square root of 2 times 2 times 2. Well, I know how to take the square root of something squared, so I'm going to group these into perfect squares. 2 times 2 is 2 squared. So this is going to be the square root of 2 squared times 2. This guy over here just hangs out by himself because there's nothing else that we can multiply by to make it a perfect square. So the square root of 2 squared times the square root of 2. Well, square root of 2 squared is 2. Square root of 2 is just square root of 2. So square root of 8 is equal to 2 times the square root of 2. So we get x is equal to, it's exactly equal to, so, plus or minus 2 times the square root of 2. And there we go. And if you use your calculator, we can double check. Turn that on. 2 square root of 2 is equal to 2.82. Square root of 8 is equal to 2.82. Okay, they're equal to the same thing. I did that correctly. So here's another situation where we have two solutions, the plus or minus. And again, because when you look at the graph, it intersects at two different places. So now I'm starting to ask myself, well, will there always be two solutions? Well, go ahead and go back to your line sheet of paper, and let's do another example on your line sheet of paper. So looking down here, example 1, the directions are going to say solve. What I'd like you to solve is 10 minus x plus 7 squared equals 10. Pause the video right now and try and solve this on your own using inverse operations. Now that you've tried this on your own, I'm going to talk through how I solve it. I realize that I need to isolate what's being squared, so I'm going to highlight, box in what's being squared. I need to get everything else to the other side. Well, the first step is to get rid of that 10. Now there's a subtraction sign separating the 10 in the parentheses, so I know I'm just going to subtract the 10 here. These add to be 0, these add to be 0 as well. I'm left with negative x plus 7 squared equals 0. Now I have not isolated what's being squared yet. I still have this negative out front, and you guys know that if there's a negative out front, that's really like negative 1 times that. We cannot distribute the negative 1 because the distributive property only works if we're not raising the parentheses to a power. So instead, to get rid of that negative 1, I divide both sides by negative 1. These divide to be a positive 1, so I'm just left with x plus 7 quantity squared. 0 divided by negative 1 is 0. Alright, I've isolated what's being squared, so now I can undo the squaring by square rooting. Square root, well, the square root of something squared is just whatever's in the parentheses, is equal to, I'm thinking, well, what times itself is 0? Well, the only thing times itself is 0. We don't have plus or minus 0 because 0 is not positive or negative. So in order to solve here, all I have to do is subtract 7, I get x is equal to negative 7. So here's a situation, we don't have two solutions, we only have one. So let's think about what this would look like. If we have quadratic equations, we have quadratic equations. There are three possibilities. You could have two solutions, two real solutions. We see those on the graph. So the graphs that we saw with two solutions, you had your parabola, and we had a horizontal line intersecting in two places. Here's a situation where we only have one solution. So I'm thinking to myself, well, where would this horizontal line intersect this parabola in order for me to only have one solution to the equation? And your answer is the vertex. So we could have one real solution, and if I did that on a graph, you'd have your parabola, and we'd intersect right at the vertex. You guys saw this with absolute value functions as well. And then we have another possibility. If I kept moving this line down and it never intersected, I will have 0 real solutions or no real solutions. Our parabola would look like this. And if you look above in the example before, when we had no real solutions, what ends up happening is you will have two imaginary solutions. So let's summarize this down here. When you have 0 real solutions, I'm going to put in parentheses 2 imaginary solutions. Let's highlight this. This is going to be an important summary. We can have these 3 possibilities. What I'd like you guys to do with the rest of class now is to go ahead and practice solving quadratic equations in your homework if there's any additional time. If there's not additional time, your homework tonight is the 7A5 worksheet in your notes packet, or in your homework packet. Nice job.